But remember, don't carry pre-knowledge that you have to here, because later it might confuse you, because my approach might be a little bit different, but nevertheless, the end result that we're going to get is the same. And so you learn a new technique already, then at the end of the day, you choose yourself which one you prefer. Okay, so remember, don't bring your knowledge to here currently. Later, then you decide. And so let's absorb the new knowledge first. So can we take a look together? Okay, under this one, we're going to learn solubility and ionic product. Now, what does it mean? So the question is, first of all, you must differentiate very carefully what is the meaning of solubility product and ionic product. Right, this is it. So what's the meaning of ionic product? What's the meaning of solubility product? Now, there are many ways to see it. So this is how I see it. Right? This is how I see it. Huh? Normally, ionic product and soluble product is used to describe whether a reaction will form a precipitate. I give you an example. Like, for example, you have a compound A, now you have a compound B. So I mix the A and B together. So this is the A and this is the B together. Now I want to find out whether it precipitate or not. So that is the main idea when I use IP and KSP, which is IP is ionic product, KSP is solubility product. So now let me differentiate for you what is the difference between them. So from now onwards, whenever I say the word ionic product, what does it mean? That means this is before reaction takes place. Let me define for you what's the meaning of before reaction takes place. So take, for example, you have A and B, you put them together and you interact, right? You put them together at the point they interact before collision. Because if you want a reaction to take place, you must collide. So I'm talking about A and B mixed together before collision. It's called ionic product. Got the meaning? They mix before they collide. That means before they react. That's called ionic product. Another one. So what is the meaning of solubility product? Now, solubility product means after reaction. So let's use this example. When you A and B mix together before they collide, just they mix at the point, mixing only. This is called ionic product before they collide. Solubility product means that I make them collide, I leave them to 10 hours, 1 day, 1 week, we don't care. Until no more reaction. That means no further reaction. This is called solubility product. So know the difference? Ionic product, before reaction, just mixing. Soluble product is after reaction, establish the equilibrium. So you notice that both of them share one thing. They are mixed together. So if they are mixed together, what does it mean? They will share the same mathematical expression because it's about they mixed together. They are about the same mathematically. Now let's take a look at a scientific explanation of what is the meaning of ionic product. You actually can link to the before reaction part. So we call the ionic product as instantaneous concentration. Now what does it mean? Because you see, right, when your A and your B interact together, they at the point when they mix, before they collide, isn't that at that point, what is their concentration? Just at that point. So we call it instantaneous. At a specific point when they mix, what is the concentration of the ion? But you see, right, this concentration can vary because your A, I can use 1 mole per dm cube, I can use 2 mole per dm cube, I can use 3 mole per dm cube. You get the idea. The value is not fixed. That's why the value always vary with the concentration of ion. That is ionic product. Get the idea? Now, then how about KSP? KSP a bit different. KSP is after the reaction. So that means that, right, after they collide a long period of time, I establish the equilibrium value. So this is after the reaction, after the equilibrium is established. What is the concentration of A? What is the concentration of B? Now, this is equilibrium. That means the value is always a constant, like your K constant value. Kp, Kc is constant, right? It's always remain the same. So the only thing that changes is temperature. You change the temperature, you change your KSP. Otherwise, no.